up there, 1734 converts it to Ethernet IP. The idea is getting the sensors on Ethernet IP so that a lot more information, useful information, can be brought to the people who are managing the operations. Another way, which we have announced about a month and a half ago, is with this armor block type IP67 IO-Link master, where you, of course, supply the 24 volts power to this, and then you can have daisy chain from here, take the power to the next one, to make it easier. This one has 8-point capability. You see 4 ports here, but by putting splitter on there, you can get 8 sensors to get connected to it, or 8 devices getting connected to it. And it gives you Ethernet IP directly out here. You see 2 cables here, so it is DLR. You can daisy chain these. And currently, the second cable is connected to my laptop for this presentation in order to duplicate this screen, which I have here on the front here. And we'll see that screen a bit later on. Right now, let me go on to the next. Let me see what else I've. Continuing on. So when we look at today, there are 3 types of I/O devices. We have the wiring for the sensors, which are 2 or 3 or 4 wire sensors. Then we have different types of I/O modules, input module, output module, analog input module. So right there are 3 of those. All 3 can be replaced. This is how we are seeing it right now. There are different modules for each sensor, analog input modules, and then actuators for the valves or other devices, and the digital input from the sensors. 3 different modules. Continuing on. So how does it change with the IO-Link? The master, which I showed you, that will cater to all these devices. So one catalog number caters to all the devices. You don't need a separate analog input module or the output module. You can connect all of these directly and communicate with them. Continuing on. Go ahead. Yep. IO-Link has been out there for about 9-10 years. It hasn't come very much, it hasn't been as successful as was it initially. And one major reason is, how do you bring all that data? And there are sensor companies which just supply sensors. There are companies that supply sensors and the IO-Link masters. But then there are different companies which supply PLCs and software for it. What we have done, we happen to be in a unique position that we have all those, and we developed the IO-Link master just within the last year. And now we are able to complete the whole package and do a premier integration with our Studio 5000 software and the PLCs, the compact logics and the control logics PLCs, that we can provide a premier integration using add-on profiles, making it very simple to install and communicate with the sensors. And we have special tag names, already controller tags created for it, which I'll show you some of the screens. Go ahead. We already talked about it, that it can replace the analog input cards. Continuing on. And then, you are going to remotely configure all the sensors. When you replace an analog input card, 4 to 20 milliamp output not being used, it's the other digital output used on the sensor, which means you don't have to use shielded cables. Noise immunity is much better if there is no conversion to 4 to 20 milliamp. You just go to directly get a distance from a sensor or a pressure from a sensor. And I'll show you some of in the demonstration over there. Now, when we come to these screens, it's kind of going into each advantage of the IO-Link. I won't use that. I will instead do it on this. Here is one of our standard sensors, which we have been selling for quite some time, and I'm going to show you the changes which are going through. This is a right side sensor. The sensor, you see a green LED telling you the power is on. If I do this, it's showing a yellow LED and an orange LED. Yellow LED is the output LED. Orange LED tells you have a very good margin. Here, it's showing just the yellow LED. It's saying it's working, the output is on, but it's marginal. It's a low margin signal, which means the lens getting dirty would make the sensor go non-operational. So it'll shut down the line if you have. So low margin indication is shown, but what happens? The only indication which is going back to the controls is just the output of the sensor. You don't come to know unless you're walking by the sensor looking for margin. Hey, how is this operating? IO-Link is going to change all that. And also, we, at the same time as we put in IO-Link in this sensor, we also changed the LEDs. We said, okay, let's make it much more visible as to what the power is and what the output is. There is no third LED, but the operation with flashing LED is shown that it's not, and you can see it all the way back there. So low margin is being shown. And with IO-Link on it, we now are communicating that signal back down there, telling, hey, the sensors, something has happened. The sensor either gets misaligned from the reflector in polarized retro sensors, or it gets dirty, and those are the conditions which send it to a low margin condition. We also put in one more on a diffuse sensor. Here, the output is off, but the LED flashing is telling us it's about to turn on. So it's a proximity alarm, kind of cautions you, hey, something is in the background, you might want to check whether that's legit condition or should not be there, type of a thing. So proximity alarm. So we put in some other extra features in the sensor at the same time. Now the idea is to send all that information here so that you can you can do preventive maintenance. Know that the sensor is dirty or misaligned, getting misaligned, and take care of it before the line actually shuts down. The whole idea is, how do you reduce downtime? The second idea is connected enterprise, the whole theme what Rockwell has, that we are connecting the operations information and bringing it to the people who are managing it, OT to IT connection, and that's where you get the benefits of being able to do preventive maintenance. I just showed a photoelectric sensor. How about a proximity sensor, inductive proximity sensor? Is there a low margin condition in that also? In the inductive sensors, always it is that don't use it in the last 20% of its range. If its range is 40 millimeter, you don't want to use it all the way to 38 millimeter or 35 millimeter. Don't use the last 20%. That is the low margin area. So that again tells you vibration causes those things to kind of get out of range or get into that area, marginal area. Again, we'll send that information back to the sorry, folks, I may have. Okay. So that causes issues that it can be. Now, what are other things which really go into when some problem does occur on the floor in trying to change a sensor? Let's say you have found that the sensor has gone bad and you need to change the sensor. The sensor may have a setting of certain sensing range, and now you need to program this or adjust the sensor for the same range. Sensor may have normally open or normally closed to be selected, or light operate, dark operate. You have to remember that to do that, and the person who is doing it is not going to right away be on top of what is to be done. So if we were able to replace the sensor, automatically configure all the settings which were originally there, then it makes it a lot more easier. So that's one thing which we call automatic device configuration. I'll demo that in a second. That's the first benefit which I will demo. But overall, when I go through these benefits, you will see they all tie back to reducing the downtime. Preventive maintenance being one part of it, but once you have had a problem with it, you have a problem, you want to find where that sensor is, how are you going to find where is that sensor? Here we are going to do some things which will show how can easily that sensor be found, and then are you going to have to read all the writing on the sensor sensor to find what catalog number I need to be getting now, and after a while, maybe it's not that legible on the sensor. In a sensor, when the sensor ships from the factory, it has a long sensing range. You may program it for a shorter so that it doesn't see too far out there. And for example, this sensor, people can see the yellow LED coming on here. It's got a sensing range of only a few inches to this dark grayish target. Usually the sensors have a longer range to a white target versus a black target on diffuse sensors. This sensor has a certain reading in there as to what the setting has been for the sensing range. And that reading is what you see up there as 900. I have on this demo the capability to change this to the default setting the way the sensor ships from the factory. So I have a generic demo where I will connect this sensor and set it to the factory default and read that reading on there as to how much. And it's says it's 20. That's the factory default setting, but when you look in here, that's where you right away see the difference that this sensor now is at its maximum range. This sensor has a maximum range of about 32 inches for white paper. So I have now, so you now have a sensor which is coming from your, let's say, stock room that you want to replace it, and you go back, put that sensor from the sensor which was faulty and you remove. And that sensor should now automatically go to configure to the previous settings. And you will notice that this sensor is now set to that. And if I try reading that, it's taken the reading. Where is the reading stored? The setting for the sensor is stored in the PLC. So it's downloaded that setting automatically. And that makes it the life a lot more easier that when you're changing the sensor, you don't have to be going back and looking at the record, how to set it up and lose time in that.
Quick question.
Yes?
I know it's IO-Link is like the name of the technology, but what's the actual, what method are you all using, or protocol are you all using for communication?
IO-Link is the standard for that protocol. That actually defines the whole communication protocol.
IO-Link is like a 232 connection, like a serial-to-serial connection, or no?
It's just completely different standard. That's why it came up as a, and so it has those bits assigned to who is the vendor, what is the catalog number, actually even a serial number. All these sensors used to have date codes in there. Now they even have serial number inside. So each sensor has a serial number. So it is that bit stream. You would also say, okay, so this is what happens because we have created controller tags. I'll show you screen on that. On this screen, you see that we will already created controller tags to show what's the sensors. Is the output triggered? Is there a low margin alarm or proximity alarm? In case of this is a laser measurement sensor. In this case, it's telling the distance directly, not using the 4 to 20 milliamp output. This sensor has a 4 to 20 milliamp output, but we are not using that. We are using the other output, second output, and putting IO-Link on it. So directly going in there. So we have created this. But if you had somebody else's sensor, you will need to write the program to be able to decipher all those bits which are coming back. That's where Premier integration helps in bringing it all together with our overall system. Let me show you the diagnostic part of it. On this screen, you see all these, here is a communication loss. So if the connection gets lost to a sensor, usually one thinks, well, maybe something is in front of it. One doesn't right away think that this connection is lost because you don't come to know what's going on. Only when a jam occurs or some other problem occurs, then you find out, oh, gee, what is the problem? And eventually you find it's a connection. Here, if I disconnect one of the sensors, and it's the from the bottom, I'll connect the second one. There is nothing on the last one. That's why you see that failing. So here you see that right away that it detected that there is a communication fault. This is a sensor which we were talking about, low margin alarm. Here you see the output is on, the first column, and then there is another green coming on, which is low margin. But it's saying it's good margin. If I do go out to some place where it is low margin, it's sending the signal back saying lens is dirty or it's misaligned. Something has shifted. So these are the things which now are getting communicated back. If I keep going out, further out, I am not getting detected, but here is that proximity alarm coming on. The idea is all these events all these conditions are being sent back so that one can take action on it and prevent the line from going down by taking an action before the sensor stops working. And also on this screen, you can see this particular sensor, which is the laser measurement sensor, is detecting the distance and directly telling in millimeters the distance. And we have pressure sensors. We have just recently launched pressure sensor. This pressure sensor has a 4 to 20 milliamp output, but also IO-link output, on-off output or IO-link output. So IO-link is going on that line, which is usually just the discrete on-off output. And that's the pin number 4 on standardized by every supplier on the sensors. We also have temperature sensor. This one we introduced about 2 months ago, and the model with the display is coming out in another month. And that sensor also with the display, the display model will have IO-link on it. I'll mention one more thing, which is multiple profiles. There are sometimes applications where the sensor's setting needs to be changed when the shift is changing or when the product to be detected is changing. You have to either change the sensing distance or you have to change some other parameter on the sensor. And that requires downtime now because the lines need to be shut down. And there may be several sensors which need to be reset. What can be done here is that you assign different profiles and store those profiles for the sensor, and then select the profile you want to be using. That way, it's right up here that we can make the decision instead of having to, and then change all the sensors right from here, then having to go and teach those sensors. A typical example for that type of an application is a color mark sensor. These sensors are usually, you see the red light up here. These sensors are usually mounted very close to ½ inch away, and they are looking for the color mark on a package, which let's say they use that as a registration to cut the package and for bagging products. And these sensors, those bags may have completely different, when one product is, hot tamales is running, it's a different package. The Skittles may have different color mark and all that. And you have to change it, and you have to go back and reteach the sensor, and there may be several. Versus it can be done right from here, and you select the profile which you want to select. You can do some trending. You can check the history of what's going on with the sensor, for example, for the last, let's say, several minutes, and keep it recorded if you want it, so that if there is a problem, it can be detected. It can be gone over the history to find what has been going on with the sensor. Bill of materials is the other thing that you don't have to go back looking at which sensor is it when you have to replace. It should come up and tell you, right now the screen is going a bit slower. It should come up, and this here is showing the application-specific name, which you can assign to a sensor. You can tell this is a CRM1 sensor, it's the Web1, or you can say conveyor number 4, sensor number 10, in-feed sensor or out-feed. You can give it application-specific names, to these sensors as well. So this is kind of a suite of things which can be done and all sent back as information back to the controllers. Now, in addition to this, what we have done is, in this module, which is IP67 module, which I mentioned, this has 8 inputs. This can actually do timestamp. What time did an event occur? Exactly, and it tells in terms of hours, date, hours, minutes, seconds, up to the last second. It'll tell when something happened, a connection loss, or another event, for example, low margin. It'll come back and tell what. So again, very helpful in troubleshooting when a problem occurs. So the idea is to have all that information come back in a very easy to implement way. DeviceNet sensors have been there. By the way, this you asked earlier, this is more similar to HOT type of IO-Link communication, that type of technology than anything else, point-to-point communication. The idea here, when we say that we are trying to get the sensors onto Ethernet IP so that everything is available a lot more easier. But if you put every Ethernet IP, first thing is it's very difficult. Ethernet IP requires a lot more space than trying to put in these small sensors. And the smaller sensors are getting smaller and smaller. Second thing is, if every sensor had Ethernet IP, that many nodes, it becomes unmanageable and very expensive. So this is a cost-effective way of doing it. DeviceNet sensors you're familiar with, some of you may have used those. DeviceNet sensors are more expensive, so they are costly, their price is higher. Second part is to implement them, you require special media, special cabling, and that becomes a problem as well. So it hasn't been easy to implement DeviceNet solutions. This will, for sensors part of it, our DeviceNet sensors will get replaced over a period of time with this technology. And this technology, again, you're using the standard cable in same everything, nothing is changing. Nothing is changing, and it's completely transparent. By the way, these masters, the inputs or the channels which are here, they can be configured to operate as IO-Link or just a discrete input channel. So you can select it while setting it up, whether channel number 4, is it to be operating as IO-Link or is it to be operating as discrete sensors? So you can mix and match, and the sensors are completely backwards compatible that way as well. Yes?
Are the sensors all compatible with IO-Link now that they're shipping or selling?
The sensors which have IO-Link have a symbol on there, and of course on our website everything is there. These are the sensors with IO-Link. We are adding IO-Link as we go along, but it's not in all the sensors. Some of the sensors we had IO-Link quite some time back, but we didn't have the master, so we didn't announce it. These sensors, this sensor, for example, VisiSight 42JT VisiSight, it has 13 sensing modes, like laser sensors, laser background suppression, laser diffuse, laser polarized retro, laser true beam, and then the standard, beam sensors, the LED beam sensors, again, that many. And then there's a clear object sensor. This sensor is a very good sensor for detecting clear bottles or even saran wrap. It's very, and so to add IO-Link into these, when we talk about it, it's adding this, when we added it to this, it was adding it to 13 different sensors. And same thing is going on this. Polarized retro we have added, diffuse we have added, transmitted beam we have done. Those are done, but there are other models which will be coming out next year for that. And every year, like right now, our emphasis in development has been add IO-Link so that we are part of that connected enterprise and bringing all that information back for making the operations more cost effective by, the downtime cost varies in each location, each operation. I was at a Pepsi site and going over this thing and asking them what the downtime cost is, and theirs was $100,000 on a one line. It was $100,000 an hour. Went to a different plant, and theirs was $200,000. Ford says that their number is that if their plant shuts down for 1 hour and they lose the production, their cost is $1 million an hour, they say. It's not just the production, it's the productivity also of people who were at that point not being able to do anything. So huge losses can occur, and this can reduce the cost. And when you say, what is the cost, additional cost of this thing? We are pricing the sensors the same, the catalog numbers staying the same. Where is the cost then? The cost goes into this module which is being added in there, and that does add around $40 per point cost. But when you look at the benefits it can bring in, it is huge. And the advantage is also to the OEMs being able to get the machines, and if they sell this feature that, okay, we can add this cost. However, I do know that OEMs do run into the issue that, well, they are competing against others and bidding on jobs and may not want to add that cost. But I have been to OEMs who have said, well, we'll provide 2 proposals, and one sees the benefits, what it can bring in, and the additional cost is very minimal when you really look at the benefit it can bring in and lowering the cost for the end user. And to begin with, as far as the analog input is concerned, the cost of the analog input module is higher than this particular iLink module. It's almost double. Yes?
Besides Ethernet IP, and what other protocols that?
From Rockwell, it is Ethernet IP. We do not provide other protocols. There may be other companies which do provide the other protocols. It's the premier integration which we bring in with our equipment. Here one can see the events. Sensor disconnected. Right now there is no sensor connected to it. And if I did try connecting the sensor, it'll show me, and I cleared the history. Actually, I should have kept it. I should have gone to read the history, and that would have shown me that I connected and disconnected a sensor. So it will record, and what it'll do is it'll record the last 40 events which occurred. We have put in some extra features into this particular sensor, which I was showing, the right side sensor, been a workhorse sensor for us. And I'll show some of those extra features. Let's say you do have a problem on a sensor and you can see that, yeah, the problem is visible in the control room, and now you want to find that sensor. You go on the machine or on the line, and it's very hard to find a sensor in several sensors out there. And there is a feature here that you can say, show me that particular sensor, and that particular sensor is saying, here I am. So location indication is what we have added in this particular sensor. It's not in all of the sensors. We have a matrix which tells what each sensor's features are. Now, Disney World had an application where they have darkroom areas where the ride is in a darkroom area, and they wouldn't want all these lights flashing on hundreds of 50 sensors installed in the room. And you can also disable the lights. So we put in some extra features in this particular sensor. The other thing I would mention is in this sensor, we also have put in what is the temperature inside the sensor, and then record the temperature, what's the maximum ever reached, and what's the minimum ever got subjected. Since inception, and also since last power up. The other thing we keep record of is the number of hours of operation. How many hours the sensor since last power up and since the original, since inception. Again, this helps in keeping a, when when a problem occurs, one can tell what's going on. So we are recording, now the temperature feature is also in proximity sensors. And some of the new sensors which we'll come out with, we'll also have that it's in measuring the internal temperature inside the sensor, which is slightly above the ambient temperature because the sensor heats up. But it's always related in a way to the ambient temperature. Let me say, if you have questions so far, before we go into, I'm going to go into some of the use cases to show some of the benefits.
Yeah. What are the distance limitations from the sensor?
Very good. Very good. I missed on that part of it. From the sensor to the module, to the IO-Link master, it's 20 meters, 60 feet.
Okay.
Now, if we were using this device here, for example, and you can distribute it, then the limitation is that, okay, you go 60 feet, then the limitation would be here more for the Ethernet cable, 100 meters, 300 feet. So that's the second part. Now that you have pointed that out, speed. These sensors have a response time of 1 millisecond. Some of these sensors have half millisecond response time. This sensor has half millisecond response time. There is this sensor, which has a 40 microsecond response time, because when it detects the mark, it has to detect that mark so quickly because the mark is so very small in width, and the web is going fast. And normally, spec is 40 microseconds, but usually 100 to 200 microseconds is the requirement on any application. So what happens in the case of IO-Link? IO-Link ends up losing on this sensor. It's usually the sensors specify what's my speed, COM2 or COM3 port. And so on this sensor, it loses 4 milliseconds. So now it adds 1 millisecond plus that 4 milliseconds to it. However, what we find is that all our controllers in the default settings are at 20 milliseconds RTI. So in probably 90%, 95% of the applications, it doesn't even come into play. Now, there will be applications, for example, hey, this application definitely says, hey, I want the response in 100 microseconds, for example. Otherwise, I'll miss to see the mark. On this sensor, there's a second output. So this sensor has the most use also, being able to set the profiles, different profiles in there and store them. And on the other hand, the second output will need to be used, which is a fast output, will need to be used. So you end up using two inputs at that point. One as a standard input and one as a IO-Link input. But the advantage it offers is huge. Same thing on this sensor, we have a second output as well. So there are other ways to get around some of the issues which are related to speed.
Is there connection limitations too? Because it's Ethernet IP, right? So you configure it as nodes essentially.
Yes.
So are there limitations? Is there a maximum amount of nodes or a maximum sensors you can have? You're going Ethernet IP to all of them, let's say.
I would say it's more just whatever the overall system, but nothing from this side.
But your device net, I guess, is a similar comparison. You have a maximum amount of nodes you can put on a device net network.
How many, does like one sensor count as one connection, or does the block count as?
It's for example, in this case, the 1734, that counts as one node. Here, this counts as one node.
Okay.
8 sensors ended up counting as one node.
We'll probably verify.
Yeah.
How many nodes and yes.
Just count. We kind of have gone from counting connections to counting nodes in general anyway.
On the LA family and in the compact optics family, it's number of nodes, right?
Uh-huh.
I'm pretty sure.
Yeah, so that's where it'll
Right. So that clock would be one node, especially in the new LA controller.
if you can go on to the use case.
Just one question, so that 8 node thing that you had, will that translate to 8 IP addresses or a single IP controlling all of this?
Single. So it's Ethernet node which you go by. So single IP.
And earlier you also, sorry, yes. Earlier you also mentioned that, the proximity sensors, you could see a, LED dirty or something. So how would you distinguish that versus a real error?
It will come back on that screen which I had mentioned. It'll come back and show you in a descriptive tag as low margin alarm. So this bit at that point will say, hey, I have a low margin. On the sensor I was trying it on, this is channel number 3 that I believe I'm connected to. There you see the channel 3 changing as my output is on or the low margin. Right now it's showing 1 for the low margin alarm. So right here, what you see on the screen is all these 4 sensors. So this one. So that's how it'll come back and give you a message, contextualized message saying you have a low margin alarm situation. If you could go to the PowerPoint use cases.
Yeah.
That's it really quick. So there's like hard. If I don't use any connectors on the wires directly, what are the wires? How many wires is there? Like power? Is it right on the power?
No.
So
The power lines stay the same. Usually on sensors, there's pin number 1 and 3. Those are power lines. 4 and 2. 4 is always it's by the IEC standard, so every supplier does it that way. Pin number 4 is the output. Pin number 2 is an optional type of a thing. Some people put another output on there, like the 4 to 20 milliamp output on all these sensors is always on pin number 2. And some people put it that you put an input there to be able to teach the sensors. So that's how, so it's really using that output pin, which is normally just on off, to send signals. Once it sees that it's connected to a IO-Link master, it starts communicating serially.
Okay, so the main thing is, if I wanted this, I definitely want my digital input to work always, and the IO-Link would be a nice to have, like do the troubleshooting on that. So minimum wire case, you're saying at minimum I can use 2 wires and get my digital input and the IO-Link, or no, I need like 3 or...
You always have the 3 wires minimum. The power wires, 2 wires, and the third wire is the output. Yes. And output wire, which also gets used at IO-Link communication. One other thing I would mention, the sensors have put teach buttons to set up the settings and all that. This teach button can be locked so that nobody can tamper with that teach button after you have set it up. Now, potentiometers, a lot of the sensors, earlier potentiometer, and people still are using in a big way, and some people just don't want, tamper resistance of this thing is considered to be worse than this one, potentiometer. Although I would say that this is also so easy to tamper with that somebody can go with a screwdriver and all. When we designed this, we put in a locking mechanism for this potentiometer also. Once you have set the settings, whether you set it from this side or that side, and then you select which one are you going to keep. And once you have kept that, you can lock that so that then after that somebody cannot, until you unlock it from the control side. Okay. We talked about some of the advantages, and I'll mention some of the use cases and how some information comes in even better than what normal sensors can do. This sensor normally just gives on-off when it sees a target. Here I'm showing an example. This is a tissue paper, and there's a perforation in the tissue papers, and the signal level is different when you see the tissue, when you don't see the tissue, and when you see the perforation line. Now, the sensor is capable of detecting only one condition, except with IO-Link, we are able to do a little bit more. We can detect the difference between tissue completely not present, tissue is present, or the splice is present. So there are some additional things which sensors' capability increases with this type of, and this hasn't been otherwise mentioned as an advantage, but there are other things which can be done with this, and it will evolve even further as we go. Going on to the next slide, you will see another condition of that. There is a shiny material going on a conveyor. This is difficult to detect the presence of the, it's very thin, for example. Usually it's difficult to detect. Here, a transmitted beam sensor is shown, and if the shiny material is there, it's sending some sort of a signal to this, light reflected back. But it's not enough to really make the output turn on. What can be done is, here it's completely much lower. Nothing's coming back almost, or very little. But because we can see the signal level, how much is the signal level coming back, one can set the threshold and change the threshold to be that, hey, I can detect this shiny material with that, which otherwise could not have been detected. So there are some application extensions which can be done with this. Now looking at some of the cost reductions. In an automotive body and assembly, this was some example through our visits where we learned these things. If a failed sensor is detected through the visual LEDs, that's how, can take the maintenance person to find, 1 hour more to just find where that problem is and replace that sensor. If you were to say, well, how much lost in production? $12,000 per minute, $722,000. And in this case, lost communication comes to right away is detected. Application specific name kind of helps this to find the sensor. And ADC, the automatic device configuration, ensures that you can very quickly change that sensor and put it back on. So this is, you can see that the cost reduction is there mainly because biggest cost reduction comes in from the downtime. Okay, next one. This is pharmaceutical conveyor line, where in that particular case, I mean, their numbers were very staggering. That the 15 sensors to be retaught when the line is to be changed, and the different product being run, different size of bottles, and all that. And their background suppression sensors, they were having to go back and change the setting on all those sensors, either teach setting or the potentiometer setting. And the number of yearly costs, they were estimating that how many times a person they are having to do it is around $50K. Product cost of the bottle is $5 actually. They told me numbers which were much higher, but I couldn't, I didn't consider that the cost of the bottle, the complete cost is lost. So I didn't go by that. They were saying that it's $100 or even higher than that. So with IO-Link, right away, you can, do the multiple profiles and change the line very quickly. Going on. This is a tire machine. 2 analog sensors, pressure sensor, 2 analog temperature sensors. So analog input cards requiring shielded cables. If you were to look at the current solution, what's the cost of the analog input module and the shielded cables? $654. If it's IO-Link, it is the IO-Link Master, the plug-in module is $350, and the standard cable, so it's lower. It's much lower cost. And there's one more. This is a conveyor line, about 1,200 pneumatic valves on that conveyor. And conveyor is broken into 20 different sections. Currently, using 8 output modules to drive 60 valves. Special cables, connectors with multiple wires required, high labor cost. It's kind of showing what the wiring is going to look like with trying to control all those valves individually. With the IO-Link Master, so here is some of those costs, $29,000 for that many. and then how many points they will need, how many modules they will need. Around $35,000. Using an IO-Link solution, that cost goes down to about $8,600. So that's where the actuator, some of our partners, Encompass partners who provide these pneumatic valves, they have developed IO-Link modules, so that module is sitting right next to that bank. So here now the communication is IO-Link communication going back to the IO-Link master.
Well, so not that we standardize or anything, but we have a lot of fans of Keyence and like Banner. Y'all reaching out to those partners and getting them to try to use technology.
I meant when our partners would be like companies, actuator valve companies, and Keyence supplies sensors, Banner supplies sensors. They are doing their own thing for IO-Link, and some of their sensors do have IO-Link in it. And they'll work with our equipment, except the programming has to be done by the user because it's not going to be the contextualized messages, the faceplates, they're not going to come up the same way as we have done the Premier integration with our sensors. We are not able to do it with other. And that's where slight difference comes in, what we are able to do versus what other companies are able to do. So that there is an advantage to having Premier integration, yes.
Is it meant to be replacing remote I/O in the long term?
I don't think.
At least in remote I/O.
Remote I/O with Ethernet, for example.
It really kind of supplements it, because that is a remote I/O block.
Yeah.
Think about it. It
It
does
is.
digital and it does I/O with both at the same time.
I mean, it would make sense completely if I'm using more than 8. The minimum number of sensors is 8 for one of the base modules.
Yeah.
And I'm using 8 or more. It wouldn't make any sense to use remote I/O. I would completely
Confuse this.
Yeah, but so that means that eventually, Rockwell and Bradley and Rockwell pretty much manufacture the remote I/O. You guys sell that. Will that eventually be discontinued?
I am not in a position to answer that question because
I would not think it would be
I-
discontinued. It would
Yeah.
be a complement to the.
it's a complement the way, yeah, it's a complement. Now we are planning to come up with another one which is probably a year away as yet, which will have 16 points. So this is 8 point and that'll have double width here.
It does give some interesting options to our customers.
With regards to, this is an Ethernet-based solution. So, does the standard have any provisions to use this with other protocols, other Ethernet-based? I mean, not Ethernet.
The standard does have, the standard basically defines the communication from sensor to this IO-Link master. The other side of the IO-Link master can be Ethernet IP or Profinet or whatever, a company may want to supply.
Okay. But
Yeah.
there isn't, or
There are,
if it's from another vendor, do you know?
There-
if
there
there's
are.
any
yes.
DeviceNet or Profinet or?
Definitely would be probably Profinet, Profibus.
Yes.
From other manufacturers, right, third-party guys. Yes, so we have the protocols that they would support.
Yes.
With Rockwell automation, is it limited to controllers that have implicit messaging only? Or are you guys working on a solution for other controllers that don't have implicit messaging?
Currently it's control logics and compact logics.
Yeah, it's a good question though. I think it's something we would discuss afterwards because right now it would be the compact and control logics families that would support this.
And
800
it's,
doesn't have any implicit messaging.
right.
Right, it will respond to this.
Yeah.
Yeah, but we know where you're going with that, so I think it's some good feedback for JJ.
Yeah.
Micro understand.
Yeah, we would discuss it. That there are some issues in trying to do that. So currently, it is just sticking to those two.
Yes.
And it's the version 20, software version 20 and up is compatible.
Yeah. It's basically the AOP that you bring out. That was you mentioned that earlier. So the AOP that comes in supported from version 21.
working with Festo on this particular project?
This one was Festo.
Yeah.
But as I know, SMC is also working on it. They may not have come out with it as yet, but this one was Festo. Okay.
We'll just give our web audience a chance to chime in a question. If you have any, please either you can type it in the question panel, and we'll give you guys a minute to type that in, perhaps. And any other questions here in the room? All right. For anybody on the online, of course, you can always reach out to us. If there's any questions afterwards, we'll be happy to pass them along to JJ to answer. And we will post we'll post all the documentation from today's session online here in a little bit. And we appreciate everybody's attendance today, both here in person and online. So JJ, once again, thank you.
Thank you very much. Thank you.
Oh, applause. That's like the first time ever.
No standing ovation. Yeah, you're the story.
Oh, he said, Robert, you don't have anything different.
So, yeah, I was going for sale, 3 grand. Now I'm back home. Sitting out on the drink on porch. All of a sudden, and then I hear my phone go off. And he's like, we see this wood skate roll slowly to a tree down the street. Walk again, and the back is going so they totally out on this. They said, "I'm customer." And Lady's like, "Well, I knew you were really hard." She's like, "Well, we pulled this way up there, like, food, bags, and over the hot line for a year." And I was like, "Oh, I don't know if I." And she's like, "You accepted these up, but you bought it." And I was like, "Oh, you got me. What happened? Come on. This is not, just give me the check." Sure enough, like, I was in there 10 minutes later. You already like, what did you say? Cash. Yeah. And I was like, see. And I was like you know, stop. I want information.
And that's one of the things that's right. It's one of those things that always is a bad time. I've been once years ago. I had lots of good experiences with this. It takes you out dedication. I used to run.
That's a good about
So the good thing is that, I could take it.
Yeah.
I still keep up with doesn't really have much automation on it. There's no automation, but like on the whole, to server control on the whole. But, yeah, it's really easier than it's like within all the shit already moved in.
Right.
So we need to sign the
He's
bill.
like, yeah, trying to move all the boxes.
All right, then.
She was the check. $6,000. I was like, yeah.